Okay, so let's take a look at those two distributions. If you were graphing the distribution of X, which represents the number of passengers on any given trip, then you would have had your X list would be the number of passengers. For that's list 1 for me. My frequency list is the percent that corresponds to each of those. That was list 2. Now, if you press zoom 9, you're not going to get a very good histogram. What we want is a bar for each of those possible outcomes. So I went to my window. I changed my X-min to just below my minimum. My minimum was 2, so I'm going to start at 1. My X max, I'm going to go just above my maximum. My maximum is 6, so we'll go to 7. Each of those differ by 1, so my X scale is going to be 1, so each bar represents a width of 1 passenger. And this part wasn't necessary, but I went ahead to eliminate some of the empty space above. I noticed that my largest probability is 0.35. So if I do a Y max of 0.5, that's going to be plenty of room for the height of each of those classes, for each of those bars on my histogram. So now if I go to graph, I get a much better representation of what that distribution looks like. Now, if I did graph the distribution of C, let's turn this one off and we'll go to plot 2, turn that one on. This time I'm making a histogram. My values for this one were in list 3. The frequency list was still list 2, the probabilities that corresponded. So this is my list of cost, and this is my list of probabilities for those costs. Again, if I press zoom 9, I'm not going to get a very accurate representation, but I can go to my window and I can change my scale and everything up. I started at 300. I'm going to go 150 below that, so I'm going to start my X-min at 150. I'm going to make my X max above 900, so we'll go with 1050. This time, each class, each bar has a width of $150. And like before, to eliminate some of the dead space above, I made my Y max 0.5. You didn't have to do that, but that does get rid of some of the extra space above the heights of each of those bars. So now when I go to graph, this is my distribution. So hopefully you were able to take those distributions and compare them with a classmate, and you saw that the shape of those distributions actually ended up being the same. So the two probability distributions have the same shape. We want to discuss the center. So we know that the mean of X was 3.75. And the mean of C was 562.5. So that addresses the shape, the center. And notice the relationship between those two. The mean of X was 3.75. The mean of C was 562.5. So what we ended up with is that the mean of C was actually equal to 150 times the mean of X. If we look at the spread, the standard deviation of X was equal to 1.0897. And the standard deviation of C is equal to 162.46. And again, if you compared those, hopefully you were able to discover that the standard deviation of C was equal to 150 times the standard deviation of X. And hopefully you were able to use that information to come up with some rules for multiplying or dividing each value of a random variable by a positive number B. If we multiply or divide each value of a random variable by a positive number B, it multiplies or divides. Divides, sorry. The measures of center and location, meaning things like the mean, the median, quartiles and percentiles, by that number B. It also multiplies or divides the standard deviation. In fact, it multiplies or divides all measures of spread. Such as the range, IQR, and standard deviation. By B as well. So it affects our measures of center and location. It affects our measures of spread, but it did not change the shape of the deviation, or of the distribution. And if you think about what we saw previously about how multiplying or dividing data by a positive number affect measures of center, measures of spread, and shape, this fits very well with what we already know. So this isn't too terribly surprising considering what we've looked at in the past. So in the next lesson, we're going to discuss what happens if we add or subtract a positive number from each value in a random variable. How will that affect the measures of center, the measures of spread, and the standard deviation? So we'll pick up there tomorrow.